everybody. Today we are going to be making a big shift and moving into fractions. So last year, this was the unit that we did while we were doing remote learning for the first time. So I thought it would be helpful to revisit some of the things that we talked about last year in the spring as we went to remote learning, just to kind of get your brains warmed up, remind you what we were working on, and also for me to see what you remember and what you have retained and what we might need to revisit more thoroughly and more deeply before we move into the next lessons. So we kind of touched on, when we talked about fractions last year, we touched on some important kind of things. And so these are the things I'm going to review. We talked about how to identify fractions, right? Looking at a fraction and telling me what fraction is shown. We worked on partitioning shapes equally. So how do you break up a shape in equal parts? So how do you break something up into thirds, fourths, fifths, sixths? We looked at fractions on a number line. Whoops, forgot to write the number line part. So looking at how do we show a fraction on a number line, and then we looked at comparing fractions. Which one's larger, which one's smaller, or are they equal? So those are kind of the main ideas, the kind of main things that we're going to be taking a look at today and reviewing. Before we even get started with those, there's two really important words that we need to know with fractions, right? So if I put a fraction on here, like 1/2, just a quick review about what parts are what, because that's going to be very important. Our top number is our numerator, and our bottom number is our denominator. Okay, and just a quick reminder, the denominator tells you how many equal parts something is broken into. So if I look at a circle, the denominator in 1/2 is telling me to split my circle into 2 equal parts. The numerator tells me how many of those parts am I working with? How many of those parts do I have? Whatever the context is. So this would be 1/2 because I have one of the 2 equal parts shown. Okay, so that's really kind of key to remember. The denominator is how many total parts you have in a shape, in a fraction strip on the number line. How many parts has the whole been broken into? How many parts in the whole? The numerator is how many parts of those parts are we talking about? So let's just do a quick review if we want to take a look at fractions, identifying fractions. So I just kind of gave you an example of one, right? This is 1/2. Okay, and we can show 1/2, actually I guess I'll keep it down in a circle. You can show it on a fraction strip, right? And then if I shade, this would also be 1/2. It doesn't matter which side of the rectangle I shade, right? As long as I have one of the 2 parts. I could even do 1/2 of a triangle, right? I think you guys kind of remember this. I'm hoping you do anyway, right? You can find 1/2 of a square, and you could do it diagonally, you can do it vertically, you can do it horizontally. All of those are 1/2, right? If I wanted to do thirds, I can break my circle up into thirds. Remember we talked about making sure that when we do the circle with thirds, it doesn't look like this, because this part is not equal. So that's just a quick reminder of that. And if I wanted to shade more than one of the parts, if I did something like this, well, we'd say it was 2/3. There are 3 equal parts that the circle has been broken into, and I have shaded, or I'm talking about 2 of them, so that's 2/3. If I did the same thing with a fraction strip, I can break it into thirds. If I highlighted all 3 parts, we would call that 3/3, or 1 whole, right? Because the whole rectangle is shaded. Okay, so one of the activities today on your assignment is going to be identifying fractions. You're going to see some fractions with parts shaded. You're simply going to write the fraction. Then we talked about partitioning shapes, and I just kind of gave you an example, but Remember, if I have something like this and I ask you to partition it into sixths, there's lots of different ways I can partition this into sixths, right? I can go like this. 1, 2, 3, 4, 5, 6, and go all vertically. I could take that same shape and I could partition it into sixths horizontally. I could take that same shape and I can partition it both horizontally and vertically into sixths. And in the same fashion, I could do it like this as well, kind of do longer ones. Okay, so just a reminder that you can break up a shape into numerous ways. The key piece is that all parts are equal, right? If any one of these parts is larger than the other or smaller than the others, it's not equal parts, and therefore it's not fair. So if we're looking at this rectangle here, and this was my favorite candy bar, and you partitioned it like this into sixths, 1, 2, 3, 4, 5, 6, and said, great, I've got 6 parts. I'm going to tell you that's not very accurate, because if this was my favorite candy bar, guaranteed I'm going to want this piece, because it's a lot larger. So the key is to get those equal portions. Okay, so that's another assignment, another activity that you're going to be doing on your assignment today. So practicing partitioning your shapes into equal parts. Okay, so we've reviewed really briefly identifying fractions, partitioning our fractions. We also talked about fractions on a number line. This is the part that I'm wondering if you guys remember. So if we put on the number line 0 and 1 as our endpoints, right? And I ask you to mark where 1/2 is on the number line, we think of this sort of as a long fraction strip, right? And if you cut that fraction strip in half, you can mark that on the number line and label underneath. Don't forget that label. So you're telling me this is where 1/2 would be. If I wanted to show where 1/4 is, well, I'd do the same thing. I'd break it into half and then in half again to get my 4 equal parts. So on the number line, I would simply show it with my hash marks. And if I wanted to show 1/4, it would be here. So here's 0/4 over here, 1/4. This would be 2/4, which is also 1/2, and 3/4. And this one would be 4/4, 1 whole. Because if I filled in all 4 parts, I would have 4 out of my 4 equal parts, or the whole thing shaded. So you're going to be asked to label a number line with some fractions. Remember to include your endpoints here of your 0 and your 1, and to label all the fractional parts, and then put a dot on the fraction that it's asking you to show. So for example, if I asked you to show me 4/5, if I wanted you to show me 4/5, I would ask you to put your 0 and your 1. Whoops. Now I'm going to break it into 5 equal parts as best as I can. Remember, does it have to be absolutely perfect? No. Does it have to be pretty good? Yeah. And this one's not very good, so I'm going to try again. I need to go smaller. 1, 2, 3, 4. There's 5 equal parts. And if I want to show 4/5, I'm going to label my parts. Here's 4/5. So I'm going to put the point on the line to show that's where 4/5 is. Okay? And then the last thing I'm going to ask you to do is to do some comparing of fractions. So thinking about, okay, if I know I have 1/2 or 1/3, and I'm asked to say which one's larger, remember your symbols. Less than, greater than. Please do not draw teeth. These are not alligators. These are math symbols. All right, so if I wanted to compare 1/2 and 1/3, you can do it in a couple of different ways. You can draw fraction strips. Just make sure they are the same length, otherwise it won't work. And if I want to show 1/2 on my top one, there's 1/2. And on my bottom one, if I want to show 1/3, here's 1/3. So if this is 1/2 and this is 1/3, which one's larger? 1/2 is larger, so I'm going to put a greater than symbol inside. Does that kind of remember that? If you want to show it in a square, you can do that. Doesn't have to be a fraction strip. So one thing you want to do is, though, not do something like this where you have 1/2 shown this way and 1/3 shown this way, because it's a little harder to compare. I would have them side by side. And then I would compare side by side and have them going the same way, if that makes sense. So see, now it's a lot easier to see which one's larger, 1/2 or 1/3. Or you could even do it on the number line. So you could draw 2 number lines and label your endpoints 0 and 1. You just have to make sure your endpoints are in the same spot. Here's 1/2, and then if I break this into thirds, I see this is 1/3, so 1/2 is further along the number line than 1/3, so I know 1/2 is larger. So you can do any one of those. If you already know it, you don't have to draw a picture. I'm just reminding you how to visualize it in case this is something you don't quite remember and you need to work it out a little bit. Don't forget, sometimes fractions are equivalent. So if I looked at something like 4/8 compared to 5/10, I might want to look at it as a fraction strip. And I'm going to draw 2 fraction strips that are basically the same size. The top one I'm going to break into 1/8. And remember, see how I'm doing half of half of half and then halves again? That should give me my nice 8 equal parts. Now I'm going to do 10ths. So 1, 2, 3, and 4. That gives me 5 on that side. 1, 2, 3, and 4 gives me 5 on that side. They're okay. It's not great, but it'll work. And if I shade 4/8 on my top one, and I shade 5/10 on my bottom, you can see that these are indeed equal. And so you would put your equal sign in between. So your job today is just to go and do the review sheet. This is just revisiting our fractions. Do you remember what we did last year? Can you identify fractions? Can you partition shapes into fractional parts, equal parts? Do you remember how to show fractions on a number line? And then do you remember how to compare some fractions? Let me know if you need any help, and have fun.